Hello, and welcome to this FMSP Core Prerequisites video. These videos are designed to help you get ahead with independent study of the A2 core, ready to develop the skills in A2 Further Pure modules. There's a lot of pre-learning that you need before you tackle this one. Make sure you're confident with all of this material before continuing with this video. It helps if you've got these things to hand, so pause the video now and get everything together. This is a very short video, but do make sure that you set aside enough time to do the questions as well as watch the video. We've just got one straightforward technique in this video, which is why it's so short, but you will need to do quite a bit of practice on it, so it was decided to do this as a separate video. Have you learnt the trig identities? Some of them are in the formula book, but you do need to remember that they're there, so that when you see something that looks like one side of it, you'll think, there's an identity, I can change that. That's the idea with using these for integration. There are some functions we can integrate and other functions that we can't. But if we can change a function that we can't integrate into one that we can, then we can move on. So, there's an identity that will change sine squared of x into something with a multiple of x as the input, which we can deal with. Here's the identity. Cos of 2x is cos squared x minus sine squared x. Now cos squared x is 1 minus sine squared x, so that comes out to be 1 minus 2 sine squared x. You may have learnt this as a separate identity, or you may just learn the top one and know how to convert it. From that, we get that sine squared x is equal to 1 minus cos 2x divided by 2. And that means that the integral that I'm trying to do is actually the integral from 0 to pi of a half 1 minus cos 2x dx. And that's the sort of integral we practiced in the last video. It's a half. Integrate 1 and we get x. Integrate cos 2x and we get sine 2x times a half. Evaluate that between 0 and pi, and we get a half pi. Sine of 2 pi is 0, minus, if x is 0, we get 0 minus 0. So that just comes out to be pi over 2. So that's the basic idea. Just look at what you've got, use a trig identity to change it into something you can deal with, and then go ahead and do the integration. Sounds simple, but it does take lots of practice to get good at it. So here are some for you to do. Pause the video and have a go at this before watching the solution. Okay, I've got tan squared. You need to know what's there in the formula book and possibly go and have a quick flick through. You can't integrate tan squared, but you can integrate sec squared, and there was an identity that related those two. You may have learnt it, or you may just remember how to get it from the standard one. If you divide everything there by cos squared, you'll get tan squared x plus 1 equals sec squared x. So, tan squared a quarter x is equal to sec squared a quarter x, take away 1. The integral of sec squared, broadly speaking, is tan. So don't change the input, it's going to be tan of x over 4. If I differentiate that, I'd get a quarter sec squared, so I need to put a 4 in front to cancel that out. Integrate 1 and I get x, and evaluating that between 0 and pi. So that's 4 tan pi over 4 minus pi. Take away tan of 0 is 0, and if x is 0, that's 0. So that comes out, tan of pi over 4 is 1, multiply that by 4 and I get 4. Take away pi, which was answer C. Here's another one for you to try. Pause the video and have a go at it. Okay, cos squared x. Well, that's using this identity here again. Cos of 2x is cos squared x minus sine squared x. This time I want everything in terms of cos squared x, so I need to replace my sine squared with 1 minus cos squared, and that will give me 2 cos squared x minus 1. So that means that cos squared x is cos of 2x plus 1 multiplied by a half. So, integral from 0 to pi over 6 cos squared x dx is the integral from 0 to pi over 6 of a half cos 2x plus 1. So a half at the front. Integrate cos of 2x, and broadly speaking I'll get sine of 2x. If I differentiate that, that would be 2 cos 2x, so I need a half in front of it. Or you might have learnt that as a standard result. Integrate 1 and I get x from 0 to pi over 6. So, 2 lots of pi over 6 is pi over 3. Sine of pi over 3 is root 3 over 2, and I've got a half there, so that's root 3 over 4, plus pi over 6. Take away sine of 0 is 0, and if x is 0, that's 0 as well. And I end up with root 3 over 8 plus pi over 12. And that's answer D. That was quick, but there's still lots to be done. Go away and do plenty of practice until you're really confident with this material. I hope you found this video useful. The next one introduces an important new integration technique. See you there. Goodbye.